1.1. Parent functions and transformations. Functions of the same family have similar characteristics. The parent function is the most basic of the family. For example, f of x equals 1 is the parent function, or the most simple function in the constant family. It is a horizontal line with a constant value of 1. F of x equals 2 and f of x equals 4 are also in the constant family. Any function that follows the pattern f of x equals some number is a constant function. Functions of the same family have similar key characteristics. For example, all constant functions, f of x equals some constant, have a graph that is a horizontal line and the function has the same output regardless of the input. X does not matter. Y equals the constant. F of x equals 2 has a graph similar to its parent function, but it is shifted 2 units up, and the value is equal to 2, regardless of the input x. The function f of x equals 1 is the parent function of the constant family. There are other families of functions. The linear family, for example, has parent function f of x equals x, or y equals x. The output is equal to the input. If x equals 2, y equals 2. If x equals 4, y equals 4. If x equals chicken, y equals chicken. The parent function f of x equals x has a graph that is a straight line, that goes through the origin, or the point 0, 0. The absolute value family has parent function f of x equals the absolute value of x. Absolute value means the size. The sign, positive or negative, is not relevant. Absolute value of a negative is a positive. Absolute value of negative 2 equals positive 2. Absolute value of positive 2 equals positive 2. Absolute value of 0 equals 0. All functions in the absolute value family have a graph that is V-shaped. The parent function has a vertex, or point at the origin, 0, 0. The quadratic family has a parent function or most basic function f of x equals x squared. Y equals the square of x. The square of x is x times x, is the area of a square with side equals to x. The graph of y equals x squared is a parabola that opens up and has a vertex at the origin 0, 0. The square of a negative number is positive because negative times negative equals positive. For example, negative 1 squared equals negative 1 times negative 1, which equals positive 1. 1 squared also equals 1. 0 times 0 is 0. So graph intersects point 0, 0. Input into function to output. Typically input x, output y. Domain, range. Domain of a function is the possible input values. Typically x values. Range of a function is the possible output values. Typically y. For example, f of x equals 1 or y equals 1. To find domain, look for possible x values. X can be anything, and y will be the same value. There is no spot to substitute for x. Domain is any real number. Range is y equals 1, because f of x equals 1 regardless of input. Another example, f of x equals absolute value of x, or f of x equals x squared. Both functions have same domain and range. X can be any number, so domain is all real numbers. Y is always positive, or 0, so range is y is greater than or equal to 0. A transformation changes the shape, size, position, or orientation of the graph. A translation is a type of transformation. It is a shift of position, changes location, but not size, shape, or orientation. Only a slide, nothing more, nothing less. Horizontal translation is left or right. Vertical translation is up or down. A translation can be a combination of a horizontal shift and a vertical shift. For example, the triangle on the left side is in the top right quadrant. To move to the second quadrant, or the top left one, the triangle would have to translate horizontally to the left. The triangle is the same triangle, even has the same orientation. After the translation, if a function equals triangle is translated vertically, up or down, it becomes a new function. F of x equals triangle plus or minus some number, depending on the distance translated and whether it was up or down. For example, f of x equals 1 has a graph similar to the graph of f of x equals 0, but 1 unit shifted apart. Another example, f of x equals x plus 1, is the linear parent function f of x equals x shifted 1 unit up. One more example, f of x equals absolute value of x plus 2 is the absolute value parent function shifted 2 units up. The basic rule for a vertical shift, up or down, is if the function is equal to some parent function plus a constant number, it is the parent, shifted up a number equal to the constant of units. If it is a parent function minus some constant, shift down some units. Horizontal shift versus vertical shift. The difference is in the order of operations. If the plus or minus is before the last step, it is a horizontal shift. If it is the last step, it is a vertical shift. For example, f of x equals absolute value of x is the parent function. The function f of x equals absolute value of x plus 2 is a vertical shift, 2 units up. Because the plus 2 is the last step, the function f of x equals the absolute value of the sum of x plus 2 is a different function. The plus 2 comes before the absolute value, x plus 2, then absolute value. This is a horizontal shift, 2 units to the left. General rule is if plus or minus a number changes value before the last step, it is a horizontal shift translation. For example, f of x equals x squared plus 2 is the parent function shifted 2 units up. F of x equals x plus 2 squared is 2 units left. Translate left if it is x plus a number and translate right if it is x minus a number. Combo of a vertical shift and horizontal shift. A horizontal shift. F of x equals the quantity of x plus 2 squared plus 2. 2 units up and 2 units left. Another kind of transformation is a reflection, or a mirror over a line called the line of reflection. Any point on a graph and the point after reflection are the same distance from the line of reflection. Every point on the graph, for example, Comma the function f of x equals the opposite of x squared is the quadratic parent function, f of x equals x reflected across the line y equals 0, or the horizontal axis. Other transformations, vertical stretch, vertical shrink. For example, f of x equals 2 times x has a graph similar to the linear parent function's graph, but stretched vertically by a factor of 2. F of x equals 1/2 times x is the parent function shrunken vertically to 1/2. Shrink if the number being multiplied is between 0 and 1. Stretch if greater than 1.